last class, which is the context of the system units, or the systems that they represent data to the computer. We were talking about the graphics, and we said that this is a context of displaying a file to the computer. Computer does not understand what is a graphic or what is an audio or what is a video. Just he knows some specificities to recognize. Just one final thing to tell you here is that graphics, they are actually because we know the black and white pictures and the old systems that they present only black and white graphics to us. Still, the same context is available, and today's computers they do recognize that, and we nominate that as a monochrome, let's say, view, or monochrome property, in which we see only two colors playing in the in that graphic, or in that whatever we talk. Only two colors, they are in action. Other than that, we see other, let's say, mixture of colors, 4, 8, whatever. I asked you the question before the class, what is how you can briefly describe what is a pixel. It is one of the dots that the output system just utilizes to show you, let's say, a color, we can say. It shows you actually some sort of data. The resolution, the context of the resolution, how many pixels we have in a view. I will not say a picture, but I'm going to say a view. It depends on the some characteristics, but we have to know that as many as pixels we have in a view, as many as it is more clear to us to have a clearer view, because we may have see the first picture here and the second picture almost, because they are small, we are seeing almost the same thing. But if we can maximize the view, they are not the same. They are not hold the same resolution. Actually, this is more visible. This is more actually clear than the first one somehow. But you have to know that because of making this view here more visible and more clear than the first one, is because the number of pixels is high when we compare to the first. Here we are utilizing 16 colors only. Here we are utilizing actually true visibility. It's almost 16 million colors. It's a huge number of difference when you compare them. We keep going on. Not only the graphics, they are one of the contexts that the computer has to understand its specificities to display it to the end users, but also the audio. Computer does not understand what is an audio. Now I'm speaking to you, but the computer does not recognize what I'm saying. He does not at all know that it is an audio or not, but he knows the properties and the specificities of the voice I'm submitting. Thus, he's making you listen to me, and he's making you hear the voice, the audio. From the context that you have to know regarding the processing of the audio, that is that it has to be in a digital format. What does it mean? It means the audio I'm speaking as per the let's say trivial state of the audio. It is an analog signal transmitted, and it has to be heard by you in your ears as an analog signal. Yet, to pass this analog signal to the computer, it has to be in a digital format, because the computer does not understand what is an analog signal, and somehow he has to process zeros and ones. We discussed this earlier. Only zeros and ones. So we have to make a process before submitting the audio to the computer to change it to a digital. The computer will process the digital signal, and then after he will revert it back to an analog view, or to an analog shape, in order to make you hear it. Also, the audio might be actually transmitted with a very small shape. The format how the audio is being transmitted to the computer, also it's another context of question. It means here that we can submit different formats of audio. I give you the example. In WhatsApp, for example, if you record a video, an audio message in WhatsApp, it's not the same way I'm calling you now, I'm talking to you in Google Meet. It's not the same thing. What is the difference? The difference is the format of the audio being communicated. Yes, now I'm talking in live time, but even if I record a video and an audio and I submit it to you, it would not be the same format. The verb, actually, it's in WhatsApp, is one of the formats. Here we may talk about an MP3 to be recorded and submitted to you. Yes. What is this context of format? The context of format is actually a property given to a file, and when we talk about the MP3 here and we compare to the others, we see that this MP3, it holds a minimum size in memory that gives actually at the end the same output, which is the same voice, the same audio, the same message delivered in an audio format. So here we have options to choose from because of this property only, that it is being actually consuming less space in memory. So we may see that there are preferences. Yes, we choose this, we don't choose this. This is better and this is not better. This is much more required than this one. So those options here, those preferences here, they are due to the format. And because they are actually, it is consuming less memory, it is much more easier in being transmitted to the network, and much more easier in being downloaded. Absolutely. Also, video data, it is actually one of the contexts that the computer has to process. But remember that the video, it's just a sort of combination audio and pictures and graphs. Yeah, so the video, at the end of the day, the computer does not understand what is a video. Again, the same thing. What he understands is a collection of frames that they are, at the end of the day, images. No more, no less. It means the video, we, me, you, he, she, her, they, the people, the users, they recognize this is a video, for example. But the computer, no, he does not care even. He has to process whatever the media is, and he has to give an output, no more, no less. For the video, he is seeing a collection of frames. And what is a frame? It's a sort of images, sort of an image. One frame, it's a sort of an image. So group of frames is sort of short video, something like that. The same context when we talk about the formats in the formats of the audio, we talk about also the formats in video. And here also the formats, they give us the sense of comparing formats, and we choose from. Mainly we talk about the size and the speed and upload and download, uplink and downlink. So preferences, they are given to us due to the formats of the video. And the formats, we mean by them the extension mainly. The MP3, what is the MP3? When you say that this is an MP3 audio, I believe that you know this word earlier. What do we mean by that? It means actually this is the extension of the file. The computer, this is an extension in computer. This is a file extension in computer. The same way, the video also holds format, holds an extension that can be followed by the whatever can be also utilized to finalize a processing task. We go one step further. The machine learning, still we are talking about the presentation of the data to the computer only. Still, it's the same context. We are representing the data to a computer, but here we are talking about software completely. We are not talking about a number or a character or a phrase or just a speech I'm talking. No, we are going more a little bit advanced. We are presenting a full software, a full solution to a computer. For example, I give you an example. Let's create a website. Let's create a website to, let's say, advertise the University of Nizwa programs. For example, what should we do? We have to create a group of pages, and each one of the pages has to hold graphs, maybe audio, maybe video, maybe text, links, menu, and so on. There are so many data. All of those components, how to present them to the computer? So we are presenting a software. We are not presenting a complete bundle of data. So we are not presenting a segregated, let's say, component, one picture, then one file, then one maybe one text, then maybe one audio. All of them, they are submitted to the computer. The computer has to understand them totally. He will process them one by one, yes, but he has to understand that they are correlated somehow. We talk about machine language here. We talk about machine language. The computer understands only his own machine. His own language. In the sense of, if I talk now, I'm speaking in English. Yeah, if I try to swap and speak in Arabic, if I swap to speak in French, if I swap to speak in Italian or something like that, the computer in all cases he has to recognize what he will recognize, not my speech, but he will recognize what he understands, his own language. So everything has to be transmitted to the computer within an understandable language. Yeah, if I speak to you now, for example, in French, let's say, would you understand? No, you'll find difficulty to do so. The same way, the computer, whatever that has to be transmitted to him, it has to be transmitted in his own language. We nominate it machine language. We give it the name machine language. Whatever the software we give, a website, a full program, a system, operating system, whatever is, it has to be translated into a machine language in order to be processed and in order to be actually fulfilling its task. Otherwise, it will not do any. It will not be able to finish its job. The machine language actually we talked earlier and still we persist. It has to be only seen in a binary format, means zeros and ones only. Means basically the computer recognizes only zeros and ones, true, false, valid, not valid, available, not available. Two statuses that the computer only understands. The yes, the no. That's it. And here, actually, the computer will not see mainly in real case. It's not to see the zero passing in the wire, or the one passing in the wire. No, no, no. He will receive an electrical pulse, or he will not receive an electrical pulse. An electrical pulse means one, means true, means valid, means yes. No electrical pulse means zero, false, not valid, not available. So either there is an electrical pulse, measures 3 volts or 3.3 or 5 volts, depends, or there is no electrical pulse, means zero. Those are the stages that the computer understands only. Based on that, programs act. Based on that, programs act. No more, no less. Just one step further, programs actually, or software written to be presented to the computer, they have to be written in something that can be translated. When I told you now earlier, just let's create a website, there are rules. There are rules to create a website. It's not because I know so I do. No, no, no. You have to, so you respect the rules, because the rules that they are the tools to translate your solution into a machine language. If you do not obey to the rules, so the computer will not be able to understand. So your solution will not be translated to something that the computer can process fully. Exactly what I was saying. It has to be something that the computer understand. Even up to date and the most advanced computers or devices today available in the market, they are following the machine language in order to process anything. If they do not understand what you transmit to them, so what you are transmitted to them, you as a user, it cannot be translated to a machine language. Any questions, please? Any requests? Still talking about the case, the computer case, which is the system unit. And let's go inside the system unit now. Actually, you talk about, let's say, to put you in the frame, we talk about your personal computer at home, your desktop computer. The system unit in a desktop computer, mainly it is actually a box-like, let's say, component, hardware. And this box component is in the shape of a rectangle at the end of the day. Something like, yes, it is a box that holds all the needed peripherals, either they are internal or external, to accomplish whatever the task you need to open, let's say, Microsoft Office Word, to open a slide like this one, to open an audio, to open a video, whatever the task you want to think that you are able to do as an office activity, whatever. There have to be something in this judgeable box to act, to understand what you want to do, and to serve you. This is the system unit. This is the system unit, and this is what it does. It is the main case. Means without the system unit, the computer will not act. Without the system unit, the computer will not act. It holds the totality, let's say the majority of the processing hardware, the CPU, the RAM, the memories, these electrical circuits, the systems, the software, the system that they translate the language into a machine language. Everything is housed, is, let's say, hold it. It is saved, existent, stored inside the system unit. The storage mechanism, absolutely, because everything to be submitted to a computer has to be stored somehow, either to treat it in lifetime like what we see now. See this slide we see now, we are seeing me and you, because it is being stored in a sort of a memory. There is a memory, there is a memory inside the computer to treat the live used data. The live means in current time. There are types, we see them in future time. There is a memory to store those data in order to display them to us. Otherwise, to not be able to display. Not only to display, but to store it for usual. There are other memory types, which is the hard disk and things like that, whatever. This system unit also holds the main processing unit, which is the processor, or also nominated microprocessor, which is actually the responsible part for doing all the computational tasks inside the computer. It holds all the connection points to the external and internal peripherals. What does it mean? It means that if we want to connect, for example, a PlayStation to a computer, can we do that? Yes, we can do. How? Because of the interfaces available. There are points that we can utilize to interconnect external peripherals, even internal. If we want to connect a printer, if we want to connect two printers or three printers, can we? Yes, we can. How to? Because of the interfaces. So the system unit will do that. We'll have that, and will help us to accomplish that. This is a view of what is system unit opened. You have to recognize this graph actually is available in our book, so refer to that, please. I will not go after explaining those components, but you have to recognize them. Mainly, all the computers, all the personal computers that you may think to buy and to utilize them for your home activity or for a small office activity, they would have a case similar to this one. If you open it from inside, you'll have something similar to this one. We'll display, and we explain now, just now we'll explain some of them. But to know, for example, if I tell you what is the power supply, you have to know that this is the box that have those colored wires getting out from it. So this is the power supply. So you have to recognize the parts locations at least, because they are, most of the computers, they are having the same display, the same components, shapes, and things like that. So if you buy, for example, brand number one, and you gonna compare it with brand number 2 and 3 and so on, you'll have a lot of similarities. Differences there will be in the shape, in the size, in the little bit in the position, something like that. Other than that, everything is similar. Yes, still talking about the components inside the system unit. Still talking about the components only inside the system unit. The main connector to all the peripherals inside, internally, and to the external peripherals also, is called the motherboard. I come back to the graph. You see this green card here, the green card here, not this green here, not this green here, the expansion card. No, the green card, the green big card here down. It is the motherboard. It is the motherboard. This is it, the motherboard. This motherboard here, it connects all the peripherals, whether they are internal or external. See, this expansion card, it is connected to the wall here. Why? Because it is given from backside. From backside, it is given an interconnection. It's given an interface to the external world for a purpose, whatever. If it is a graphic card, it will give a graphical view or something like that. Whatever. It is given an external interface. And to where it is connected? It is connected to a slot available inside the motherboard. Thus, we understand that everything internally or externally, it has to be connected to the motherboard. Without the motherboard, there will be a problem. We will not be able to interconnect peripherals. Peripherals means devices, whether they are internal or external. From the components, we see they are connected to the motherboard is the computer chip. What is the computer chip? You see the black dots available here. Those are microchips. Not all of them black actually. See this black small here, black here. It is a very good example of let's say microchip. Those are sort of, they might be actually memories, but also they might be actually processing units, small processing units. They are connected to the motherboard to do a task. They are done using silicon. This is the fabric, how they are actually the material used to generate those chips. And they are done actually either to store or to make processes, no more, no less, either to store data or to process data. Other components to be connected to the motherboard is the circuit board. What is the circuit board? Actually, the peripherals, we see them, and the connection points, the slots and the whatever, they are available in the motherboard. They have to communicate to each other. They have to communicate. Yes, if you connect something in those slots here, they have got to communicate with the RAMs here. They have to communicate with the processor here. They have to receive the power from the power supply. So everything is connected to each other. We talk about circuit board. They are actually connected to each other. It's a circuit that connects all the peripherals. Mainly, we talk about chips all together to accomplish what has to be done. Actually, we don't specify anything, but everything has to be connected. Yes. A system board. System board. It's another. It's it's a group of microchips that they are actually interconnected all together. I can give you actually the example of because we have to define. There are other things we have to define, but the system board is another component. It's a group of microchips that have to be connected all together, no more or less. The BIOS or the CMOS or whatever. I can give you examples, but briefly I can give you here. You have to remember group of microchips that they have to connect all together inside the motherboard, still inside or from within the this green board here, which is the motherboard. Uh, Remember here actually it's not only the chips that they are a question of a system board, because we talk about the totality of the devices that they make the system run. It means not only the chips but everything that is responsible to run the system. They are constituting the board of the system, constituting the board of the system. Now you are seeing me, I believe, using a mobile or using a laptop or using a computer. So this is actually a screen that you are utilizing from that device. It is a monitor. This is considered to be an external device. You are utilizing an external device. External devices, they have to be connected to the motherboard somehow. From the examples we give and we mentioned, the keyboard or the mouse, or in plural mice, printers, whatever, the screen board, actually the monitors or whatever, Proximas. Um, there are numerous devices. They are doing the task of displaying the data, so they are an external device. Sorry, they are an output device, but we are not talking about an output here. We are talking about an external device in general. Either they are making an input or an output. The external device, they are all the device. They do input or output, both sides, both directions. Since they are externally connected to the case here, externally connected, so they are said external devices. If we utilize, what is the difference in between, for example, if we buy a computer desktop version or a laptop? What is the difference if we buy a laptop or we buy a tablet? What is the difference if we buy a tablet or a mobile device? What is the difference if we buy a mobile or a personal data, let's say PDA, actually, personal data device. The difference is ease. The difference is ease. The wireless capabilities. One of the differences, not only, but one of the differences, the wireless capability. Because the desktop is not equipped with, let's say, wireless capabilities, but laptops are mainly. From the example of the wireless capability that we get connected to a Wi-Fi, we use the Bluetooth to send and transmit data, files, and so on. So wireless capabilities are also computer capabilities. Wireless devices, they are to be connected. They can be connected to a computer for a wireless usage. A desktop computer, can it be equipped with a wireless device? The answer is true. We can equip a desktop computer with a wireless device. Yes, we can. But mainly wireless devices, they are for portable devices, like laptops or mobiles or tablets. Also, desktops can be equipped, but they are originally not said to be equipped with a wireless device. But yes, they can be equipped with a wireless device without any issue. Power supply, this box here, the power supply, this box here. It is the main power, let's say, supply, let's say, hardware to equip all the peripherals inside the system unit with the power. Because without the power, nothing will run here inside the motherboard. If we don't give power to all of them, nothing will run. We have to give power. And this is the power supply that supplies all with power. The batteries and the storage devices, they are actually question of the computer, because actually a system unit inside a desktop is not the same way a system unit inside a laptop. What are the differences we can see? From the difference we can see is the battery. The battery. The portable device, they are equipped with a rechargeable battery that can survive without being connected to the wall, actually, to the external power, to an external power, let's say, supply. From internally, it can survive for a few hours, 3 or 6 or 12, depends on the battery capability. So rechargeable batteries is one of the specificities of the, let's say, portable devices. Non-removable batteries, they are still also available. We can see them in the Mac, let's say, brand, the Macintosh, the Apple devices. Some, not only them, but also there are other commercial hardware equipped with non-removable batteries. This is the case actually of maybe more qualitative, yes, but they are representing a problem when we talk about replacing the battery or fixing the problem related to a battery, because you have to break in the device, and you have to find a way how to open that. The non-removable device, sorry, battery, means the battery cannot be opened. You cannot see what is the problem related to the battery. You have to find a way. It's non-removable. So there have to be a problem when you try to remove it. Absolutely. This, you have to understand it this way. Uh, uh, Drive base, other components, which is a hardware, we find it inside the system unit. I can give you actually the example here. See here, this expansion card here, this expansion card, we see it here. It has to have a place to connect to in order to do its role. We talk about a bay. We talk about a bay. Simply, it's a bay. It is a sort of a hardware. It is a sort of a hardware that has a shape to receive a device. To receive a device, no more, no less. Drive bays, they are places inside the system unit to receive devices, to connect, like, for example, the main storage device, the CD or the DVD or the, let's say, the infrared readers, something like that. Any hardware you want to connect it to the internally, this drive base, you actually talk about internal devices, not the external devices. The drive base, those bays here, they are to connect hardware, but they have to be internal. Is one of the constraints. Places inside the system unit that they fit exactly um, an expansion hardware. You have, for example, a small storage device inside the computer. You want to add, you want to increment that, you want to increase the storage capability. What should you do? You'll add a memory. Very easy. Where you put the memory? In a specific bay. Full stop. So not only the let's say the storage device, but any peripheral you want to connect it internally, there have to be a bay for that. There have to be a bay for that. The core activity that the computer does is the computation. And this computation needs to be done by the CPU. The CPU, we presented it earlier. Up to now, we present that it is the central processing unit, which is the case, this box. The CPU also, it is to be given this name here, this CPU, it is to be given to the processor. And the processor is the computational, is the hardware that does the computation actually in your computer, in your case. For the commercial devices, the personal computers, the computer you buy to use it at home, we talk about microprocessor because of the tiny shape. It is doing only small activities for your personal activity, whatever, office activity or your study activity or something that you need, you as an end user, you need. But if you talk about the mainframe or we talk about a supercomputer, we talk about a processor, not a microprocessor. Both of them, whatever the nomination is, it is a central processing unit. It is a CPU in action. This CPU, this central processing unit, it has to be connected to the motherboard. Those central processing units, there are, let's say, distributions, there are versions, means that we are going to find either brands, companies that they manufacture those processing units, those processors or those microprocessors. This is the first view. The second view, which is more important, is that the capability of computation. What does it mean? A processor will do what? It will receive only the machine language we described earlier, and this machine language would be actually computed to give you an output, you as an end user. The machine language to be received and computed, there is actually, it's not there have to be, there is a celerity, there is a speed of computation. This speed actually can be different from a processor to another. Why? Because of the architecture of the processor. When you talk about the processor architecture, actually the examples we see, and they are presented to us here, the dual, the quad, the multi-core processors, they are examples of commercialized processors. Let me pass to to this graph here, to this table here, to show you. A processor is actually given for dedicated computers. This is a server, has up to 16 core unit in a CPU. What does it mean? Dual core, quad core, multi core, 16 core, N core. What does it mean here? What does it mean? It means that the CPU is having 2 layers for the dual core. Two. Quad core, it is having four layers. Multi, it depends on how this multi is. And when you talk about 16 here, 16 in this example, it has 16 layers. What is the layer? A layer is a CPU itself. A server might have 16 processors like this one. They are on top of each other. In a very small area, they are having 16 layers to do the same process actually that a one single CPU can do. So if one single, let's say, processor or microprocessor can finish a task in just 1 minute, for example, a dual core processor will do it in half minute, 30 seconds only. A quad core will do it in 15 seconds only. A 16 core will do it in 5 seconds only. This computer, if he utilizes 16 core processor, will finish the job in 5 seconds. A one core will finish the job in 1 minute. See the difference of time. So the speed of computing to finish a task, it is based on the architecture of the actually it counts on, it's not based on, it counts on يعتمد على, it counts on the architecture of the processor. This computation here to be done, there is a unit to measure that, which is the gigahertz. The gigahertz. So whatever the architecture is, there is a speed of computation. There is a speed, and the speed unit is the gigahertz. Like we talked about the bit byte, kilobyte, megabyte, gigabyte. Now we talk about 1 instruction per second, 1 kilo instruction per second, 1 gigahertz instructions per second, and so on. There is, we'll explain this in a while. We'll explain this. But you have to know that the speed of computation that the processor do, whatever the architecture is, in a server, in a computer, a desktop, or a laptop, or a mobile device, the unit is the gigahertz. The unit of measurement is the gigahertz, no more no less. I stop here. We'll come to that and we explain in details the context of the speed dust. We'll come to that now in a while. Here, yes, here they are. Any questions, please? Any questions up to here?
No, Mr. Thank you.
Khalifa, any سؤال؟
No, Mr. Thank you.
Asail, any سؤال? Okay, let me do the attendance, please. اسمع اسمك, you write yes, please. I'll stop the recording here. You write